Hello my dear students, welcome to this next video. Here we'll be doing question number 35 from GATE 2024 paper. The question is from vector calculus. So can you see in this video you are doing every question in 2 minutes, right? So it's very simple when you are going here and there. You can just do this series, right? Because sometimes what happens, we for starting a subject, right, for doing the theory, sometimes we are reluctant because we think that we don't know that subject, but when you do some questions, then you realize that that is a good subject and you can do it, right? So it's a good idea that you do some questions, right? So this question is from vector calculus, right? So it's very simple, but we know we have to know certain things which we'll be discussing here. So if the outward flux of this function through the unit sphere is alpha pi, then what is the value of alpha? And you have to round off to the two decimal places. Your answer alpha should be rounded off to two decimal places. Now, one thing you should be knowing, what is outward flux. So you see you are given a unit sphere. So this is your unit sphere, x square plus y square plus z square equal to 1, and this is a function. Outward flux is basically how much, if suppose this is some field, how much is going out, right? Like in very rough sense we can talk, say like this, right? And if we talk about the formula, that is actually whatever is your function, vector valued function, dot product with whatever surface you have, you take a small element of that surface and then you integrate over that surface. So here the surface is the unit sphere. So this is the definition of outward flux. And in the theory of fluid dynamics or fluid mechanics, it's very important, right? Definition of outward flux. And you must have seen that in physics also, electromagnetic field or electrostatic field, there you do this flux thing, right? Now, this is what we have to find out, and for making it easier we have something called Gauss divergence theorem, right? So this is very important. Gauss divergence theorem, what it does, it changes a surface integral to volume integral, and that is easy to integrate. What it says, that the surface integral, it changes surface integral to volume integral, right? So it says that you take the divergence of your function and then you take the volume integral over whatever surface you were talking about. For example, we were talking about the surface of the unit sphere. Here is the volume of the unit sphere, right? So this will be over the unit sphere x square plus y square plus z square less than equal to 1, because that is the volume. Divergence of this function, right? So your function is x cube I cap plus y cube j cap plus z cube k cap. So divergence of f would be, let me just calculate here first. So divergence of f would be the derivative of f with respect to x I cap, sorry, this is a scalar quantity, plus derivative of f with respect to y plus derivative of f with respect to z. So that is going to be 3x square plus 3y square plus 3z square. So divergence would be 3x square plus y square plus z square. And what is a volume element? That is dx, dy, dz. So now you have to integrate. Now we know that because we have a sphere over which we want to find out our volume integral. So it's always a good idea to change your coordinates to spherical polar coordinates. Let us change the coordinates to spherical polar coordinates. Okay, so if I do so, if I change my coordinates to spherical polar coordinates, so what we have x is equal to rho. Okay, rho, you have just a minute, yeah, sine theta, rho sine theta, okay, I'll take it as sine phi. So basically what happens, if you have rho here, suppose this is my x, this is my y, this is my z, then you have, if I take this angle to be phi, right, and this angle to be phi, so this becomes rho sine phi, and this becomes rho cos phi, right? So your z is rho cos phi and x is rho sine phi, and then you have theta here, rho sine phi cos theta, and y is rho sine phi sine theta, right? This is the transformation. Sometimes people call theta this angle and phi this angle, doesn't matter. So from here you can actually find out that the dx dy dz is, I'm not driving it here, but this is equal to rho square sine phi rho d phi d theta, right? And your sphere x square plus y square plus z square less than 1 is covered by rho varying from 0 to 1, okay, rho varying from 0 to 1, and then uh, phi ranges from 0 to pi, phi, this angle ranges from 0 to pi, and your theta ranges from 0 to 2 pi, because this has to be full. Theta ranges from 0 to 2 pi. So you can do that here. So this will become limits of theta here 0 to 2 pi, limit of phi 0 to pi, limit of rho 0 to 1, and this will become x square plus y square plus z square will become rho square, and in place of this I am going to write rho square sine phi d rho d phi d theta, right? So this will be, first we have to integrate with respect to rho. So what we will be getting, we'll be getting this is 3 rho raised to a 5 upon 5, okay, 0 to 1. Then you have sine phi d theta, phi from 0 to pi, theta from 0 to 2 pi, and this is equal to 3 by 5 outside. So you have 0 to 2 pi, 0 to pi, sine phi d theta. So that will be 3 by 5 negative minus cos phi 0 to pi, and then also for theta you have 0 to 2 pi, independent, everything is there, so you can integrate like this. So this is minus minus 1, and then you have minus minus 1, and then you have plus 1, right? And then you have 2 pi. So this is equal to 12 by 5 pi, right? So this is our outward flux. Now if you look at your question, right? So question is, it says that it is alpha pi, right? So you have to put it, alpha pi is equal to 12 by 5 pi. So alpha is 12 by 5. So that is nothing but 2.40, right? So this is your answer, 2.40, because they ask you to round off it to 2 decimal places. Thank you for watching this video. If you have any doubt, please write in the comment box. Please share this video and subscribe to this channel. Happy learning!